Hey, good morning, everybody. I hope you're fine. It dawned on me that we've been out of the actual physical classroom now for 2 months as of yesterday. So we're all kind of in the groove with this. I'm still trying to do things better. And so let's just go on and we'll see what you can learn today about the reciprocal function family. Now we have basic shapes of graphs that we've talked about before. We started off with the absolute value function that made v's, and then we had our parabolas that made the u shape, and we've had our exponential function which made kind of like a J curve. And so we've had a whole bunch of different shapes, and this is no exception when you have a reciprocal function. In other words, you've got y equals something over an x. Now it's not an x to a power, but just something over an x. We have what we call a reciprocal function. So we want to, just like we've done with other graphs, we want to start off with just looking at some ordered pairs to see what happens. So when we start looking at ordered pairs starting at 1, 2, and so on and so forth, 4 over 1 is 4, 4 over 2 is 2, 4 over 4 is 1, 4 over 8, I'm doing things on purpose, these have been chosen ahead so we can take a look, is a half, and 4 over a half is 8. And what we notice in this is we notice that the answers kind of make backwards patterns of each other. And when we graph our points, we have something that looks like this. Now, if we stop with just the positives, we don't have a good picture of what the entire graph looks like. So we've got to take a look at the negatives as well. So in our negatives, if we do the same thing with -1, really the only thing that happens when you're plugging in a negative instead of a positive is you get the same answers, but with a negative in front in this case. So when we graph -1, we get -4, and so on and so forth. So what we find is we find this neat looking graph and a reflection over here and a line that goes right down here through y equals -x. That would be where you would reflect it around. And this would be our basis for our reciprocal function. Now this number up here, okay, this number up here is going to be very important to us very shortly. It shows how stretched out the graph is, and we'll get to that shortly. Okay. Now something that we've kind of hit on before, but we need to hit on better, is the idea of asymptotes. Now asymptotes are basically imaginary lines where a graph is getting closer and closer and closer to that imaginary line. Now in this case, where x equals 0, which is technically the y-axis, okay, the graph from the positive side is getting closer and closer and closer to it, not crossing it. And then from the negative side, it's getting closer and closer and not crossing it. And if you think about it, when x equals 0, you don't get a value at all because anything over 0 is undefined. So we have this place where you're getting closer and closer, infinitely close to 0, and then there's a jump. Now when you put this in a graphing calculator, sometimes it actually shows a line going up here, which is really incorrect, because there isn't really a line here. This is just an imaginary line, but I've got it done in dashes here so that you can show the format for your graph. So I do want you to sketch in the asymptotes, even though they're not really part of the graph, they're what your graph is approaching, so that you can pay attention to what's happening. Now we know our x values are related to our domain. So our domain means x can be any number except for it can't be 0. Because when x is 0, this whole thing falls apart. Now what we notice about the range, what we notice about the y values, is that they are approaching this line right here. They're not crossing over it, but they're approaching right here. So what happens is in this direction also we have an asymptote. We have a value that is not going to happen. Okay, and if we were really to think about it, if we tried plugging in a 0 here, and then you tried solving for x and you multiplied x times both sides, you would have 4 equals 0, and that's impossible. So you have an asymptote here and you have an asymptote here. Your graph is going to approach it. We're going to do some very rough graphs in this section. And the asymptotes are going to be really the key thing that I'm looking for. We're using some other points for form. Now, what I want to talk about is what happens when this number changes. Okay? Really, our pure parent function for a reciprocal function would be if this was a 1. Okay? Right here. Here's our pure parent function. Ignore the colors here for a minute if you can focus it in on the black one. Okay, so we've got 1 over x. This is our parent of all of our reciprocals. So if we think about it, 1 over 1 is 1, 1 over 2 is a half, 1 over 3 is a third, 1 over 4 is a fourth, 1 over a half is 2, and so on and so forth. So you have what happened before, you have a nice reciprocal, you've got the asymptotes right here. Now, if nothing else changes except for the value, the number that's on top, we already looked at what happened when a was 4, when the number on top was 4. It looked kind of like this except for, if we look at this, at 1 we had 4 instead of having, at 1 we had 1. When a is 6, we have 1, 6. When we have 0.25, we have 1 and then 0.25 because you're dividing whatever that a is by just 1. So what ends up happening is all those values fall in line. They're still approaching the same asymptote. But in this case, we would say it stretched, and in this case, we'd say it compressed or it shrunk, or we had something like that happening. So you can use the word compression or you can use the word shrink. It's getting closer, in other words, closer down, smushed closer to the asymptotes. Okay. Then we have this one in green. The green one with the negative is a reflection. Okay, just like we had reflections before, it's 6, like if we look at this red one, but then the green one reflects across the x-axis so that all these points are brought to the other side. So here would be our a equals -6 graph, just like this. So what we can kind of see is the same thing starting to come out as happened when we did the other graphs. And so we need to talk about your HK is coming back, your stretching and compressing is coming back. So we have those things to deal with. So here we have this. And on this, we have the same rules applying for this a value that we had before. You've got a stretch if it's bigger than 1. You've got a shrink or a compression if it's smaller than 1. And if it's a negative, it reflects. So this is the same thing. You can use the word shrink or the word compression. Either one is fine. This h value takes us left or right, and the k value takes us up or down. And we have to remember also that x is not allowed to equal h because that'll give us a 0 in our denominator. So we've got to watch out for that. Now, what we can do is we can analyze describing the translation just like we have done many, many times before. What's happening with all of these numbers? So think about it for a minute. You might jump ahead a little, but this one means that it's going to stretch. This one here means it's going to go which way? Left one. And this means it's going to go down 4. This 1 means it's not going to stretch or compress, it's just going to sit there. This minus 3 means it's going to go which way? It's going to go right 3. And then this one means it's going to go up 2. Okay, so stretch 3, left 1, down 4, right 3, and up 2. So then after we've identified them, we are going to be making some graphs, which means you have to be able to identify what's happening. You have to be able to identify the asymptotes. Now, the examples we showed before, the asymptotes were all at 0, 0, but really the left and right and the up and down are going to show us where our asymptotes are. They're not always going to be on the axes where x equals 0 and y equals 0, so we need to bring you through that process. Okay, when it says the whole graph moves left 1, left, if we're thinking about our x and y axis, that's an x direction, so everything's moving left 1, so that means x equals negative 1 is an asymptote. Down 4 means in the y direction we have y equals negative 4, and that's another of our asymptotes. So when you're doing a very rough sketch, you're moving an asymptote left 1, so you've got one going this way, and then you're going down 4, so you've got one going this way, and it looks like this. So we have left 1, x equals negative 1 is one of our asymptotes, and down 4, y equals negative 4 is another of our asymptotes. Way back in the day, don't forget you learned to graph the x equal and the y equal value. And then what you're going to do is you're going to sketch in your values here. Now, it's always good to have the best form that you possibly can on these graphs, so it's not really a big deal even in your head to plug in a 0 in order to get your y-intercept. So when we plug in a 0 here, 3 over 1 is 3, minus 4 is negative 1, 0, negative 1, here's a point. And then after you have that 1 point, just taking it very nicely and curving it down around. The more precise that you're required to be the graph, the more you'd want to throw in some extra points. But right now we're looking for you to know what the basic shape looks like. So you're not ever done when you do the first one. You have to then do the one that comes on the other side of your asymptotes. Okay, so same thing here. I have 1 over x minus 3 plus 2. There's no stretch here, but it does go right 3. And up 2, which we already talked about. And so this right 3 means what about the asymptote? It means that the asymptote is at x equals 3. And it means here, this up 2 means that the asymptote is y equals 2. So we move the asymptote right 3. 1, 2, 3, x equals 3, and up 2. And then I didn't even pick values here, I just put these in. If we plugged in a 0 here, okay, x equals 0, we would have negative 1/3, and 2 plus negative 1/3 is 1 2/3, which is about where this came in. I am interested in seeing you have some approximate things. Your y-axis, your y-intercept should be as close as possible to being correct, but then your basic shapes I'm looking for. So you've got your asymptotes, it's approaching those graphs, and that's your basic shape for them. Okay, so we could talk about domain and range on each one of these. Okay, the domain here, the x values, is everything except x does not equal negative 1. And here the range would be y does not equal negative 4. Our domain here would be x does not equal 3, and our range would be y does not equal 2. And we've got some more to do. Okay, another one that asks through all the questions. We want to describe it, we want to find the asymptotes, we want to sketch it, and state the domain and range. Okay, that's really what we were just doing, but what I want you to do is pause it right here, and I want you to see how you do with this and then listen to the explanation. Okay, so describing the graph. We have a stretch of 2, we have a right 1, and we have a down 3. I didn't even write in the stretch of 2. The asymptotes. Okay, our asymptotes are important. Right 1 means x equals 1. Down 3 means y equals negative 3. So x equals 1 pulls this one over 1 unit to the right, and down 3, down 3. And once again, I am mostly interested in you being able to find those asymptotes and get the basic graph here. Our domain, remember, goes with the x values. X can be anything except for x is not allowed to be 1. The range y can be anything except y is not allowed to be negative 3. So that's how we're going to be showing your domain and your range. Domain and range are going to be huge for those of you that are heading in the pre-calc direction and the calculus direction. Okay. Now, if you have a parent function and you want to find the translation, now be careful. You have to know what parent function you're doing in order to ever do the translations of them. But here's our parent function. X equals negative 2, y equals 5. So you want to put in your values here. Remember, the x one is the one that's kind of backwards. So when you've got a negative 2, you're going to do a plus 2 with your x, and with your y, you're going to do a plus 5 on the outside. Okay, so you're writing your own function here. The 3 in the numerator stays with that, and then in the denominator, remember, if you want to check and see if you've got it right and did I make this work out right, when you plug this in, this is the one for an asymptote to be there. It's a value that doesn't work. So when you plug this in and you get a 0, then that should be your clue that you got this part right. Okay, so let's think this one through. Asymptotes x equals 3 and y equals negative 4. Okay, same thing except for this one is going to give you x minus 3 in the denominator, and then a minus 4 is going to be hanging out by itself out here. Okay, so you need to be able to do the things where you answer all those questions that we just answered, and you also need to be able to write an equation if you're given some parameters like this. Now sometimes before you can solve it, you've got to actually solve for y, just like there were other times you had to solve for y. You're not even going to be able to let your calculator help you. Notice I didn't use it because, like I said, there's some strange things that happen with the asymptotes on the graphing calculator, and it actually makes it look like something's happening that isn't. So we're going to solve it for y. So we need to add 3 to both sides, divide by x. And then if we wanted to sketch the graph, we do not have anything. It's not going right or left. It's not going up or down. So it's just got the asymptotes on the x and y axis. And the ordered pair 1, 8, if you plug in a 1, you're going to get an 8. And so that gives it a nice shape to it. Reciprocal function tells us that 8 and 1 also works 1, 8. And 8 over 1 reciprocal. In other words, those numbers act like reciprocals. Okay, so I'm through the whole lesson. However, I realized that I went through it fast. So at this point, If you get it and you want to go right to the homework, you can, but I'm going to do one more slower for those that need to see it one more time. So let's finish by it for those that are cutting out, but here's one more that we can work on together.